Hello and welcome to yet another video of Cornerstones of Math. Today we are going to solve a calculus problem that looks nuts but actually require only basic formulas and theorems in order to solve it. So the problem says, a function fx is defined as integral from sine x to cosine x of square root of 2 plus sine t plus cosine t. This function is surprisingly well defined for all real numbers x. Now we have to find its derivative f prime x. So how can we find it? Well, although the function itself looks a bit complex, this is just a simple finding the derivative of a function that is defined as a definite integral with x at either lower or upper bounds of the integral type of problem. And many of you who learned the fundamental theorem of calculus might already know the general process of solving this. So the first step is letting this part of the function as gt. Then let capital Gt as one of the antiderivatives of small gt. Then we can express this function fx as integral from sine x to cosine x gt dt. And by the famous fundamental theorem of calculus, we can simply write this as capital G cosine x minus capital G sine x, right? This is nothing more than a simple fundamental theorem of calculus that we use to calculate the value of a definite integral. Now we have to differentiate the right-hand side to obtain the derivative f prime x. And since this right-hand side consists of function composition, we need to apply the famous chain rule, which is the derivative of a function composition g of fx can be calculated as g prime fx times we have to multiply the derivative of the fx. So we have f prime x equals, if we differentiate this part, we have g prime cosine x, then we have to multiply the derivative of cosine x, which is minus sine x, minus, and from this part, we have g prime sine x, and we have to differentiate this sine x, so we have cosine x. So if we write this minus sine x first, the derivative of capital G is simply small g, so we have small g cosine x, and for the second term, if we write this cosine x first, then we have small g sine x. And since gt was defined as this, the derivative is minus sine x times square root of 2 plus sine cosine x plus cosine cosine x minus cosine x times square root of 2 plus sine sine x plus cosine sine x, which is also well defined for all real numbers x. So we have found our answer, but let's actually do one more thing before I finish this video. The graphical visualization using the Desmos graphing calculator. So here is our integrand function gx. Then we have this function fx, which is defined as the integral gt dt from sine x to cosine x. And the cool thing is, Desmos can actually calculate and plot the values of the function defined as an integral like this. So we have this blue graph of the function fx. Next, let us plot the derivative of the function fx. Another cool thing about Desmos is, it can actually calculate the derivative of a function even if that function is defined as an integral like this. And this dashed line is the graph of the derivative. Finally, let's take a look at this function hx. This function is defined using the exact expression for the derivative f prime x, which we have just obtained. So you can clearly see that it is defined as the answer that we have obtained. Now this function hx must have the exact same graph as this derivative f prime x. And guess what happens if we actually plot this graph of hx? Voila!